Hello, time for our second review on lines. Today we're going to start off graphing lines given the slope-intercept form. First example, y equals negative 2x plus 5. Graphing from slope-intercept form, you'll recall, is pretty easy because we're already given our slope and the y-intercept. So from there, we can just take our coordinate plane and fill in the pieces, starting with B. Okay, start with B. We'll start with the y-intercept. So y-intercept is a positive 5. And then we're going to count out a slope of negative 2. So negative 2 means we go down 2 and then to the right 1. So down 2, right 1. Down 2, right 1. Get a couple of points and then we connect the dots. And if we did it correctly, we get a line. Noting it's heading down because our slope is negative. Pretty easy. Second example. Y equals 3/2 x minus 2. We need a coordinate plane to start from. Now, if you have graph paper at home, that may be helpful to you. If not, you can freehand like I am. On the worksheets I'm putting up, there is graph paper built into them. Now, if you can't print them, you're going to have to do the hand sketches like I'm doing here. Start with the y-intercept, which was negative 2. A slope of 3/2 means we're going to count out a slope of 3/2, which means up 3 and to the right 2. So up 1, 2, 3, right 1, 2. Up 1, 2, 3, right 1, 2. And again, we should get points that form a line. Positive slope, arrow is heading up. Second topic for today is going to be transform equations. What happens when we're given an equation that's not in slope-intercept form? So we can transform them back into slope-intercept form. And It's just simply taking our example and we have to solve for y. So we want to get y by itself. So in this case, 2x plus y equals 5. We subtract the 2x from both sides. We're left with y equals a negative 2x plus 5. Always write your x variable term first and the constant at the end so that you're in the true y equals mx plus b slope-intercept form. Our next example will increase the difficulty. 3y plus 6x equals a negative 9. Again, to get y by itself, we're going to get the x term over to the right. So we have to subtract that 6x. We're left with 3y equals negative 6x minus 9. And our last step, divide through by 3. Y equals negative 6 divided by 3 is a negative 2. Negative 9 divided by 3 is a negative 3. So we get y equals negative 2x minus 3. One more example on these. 2x minus 4y equals 3. Subtract over that x term. We're left with negative 4y equals negative 2x plus 3. And now divide through by the negative 4. This time they're not the nicest of numbers. That's okay. We're left with y equals negative 2 over negative 4 reduces to a positive 1/2 x. 3 divided by negative 4 is a negative 3/4. Leave it in fractions. Okay? As we told you in Algebra 1, we like fractions, and as we move through Algebra 2, everything is going to be in fractions. So get used to it again now. Leave your numbers in fractions. Do not convert to decimals. Our last topic of review in this video is the graphing using the x and y intercepts. A few examples to look at. In this case, we're going to have problems that are not in slope-intercept form. Okay? And instead of taking the time to solve it for slope-intercept form, we're simply going to use the cover method to determine the x and the y intercepts. We need a place to record them, so we're going to make ourselves a little table. And we're going to look. When we plug in a 0 for x, that makes the first term go away. 3 times 0 is 0. So that first term goes away. We're simply left with negative 2y equals 12. Well, what times a negative 2 gives us 12? Negative 6. Divide the negative 2 over. 12 divided by a negative 2 is negative 6. That gives us our y-intercept. Our x-intercept means we're zeroing out the y term. So we're left with 3x equals 12. 3 times 4 equals 12. And that gives us the second intercept. Once we have those, we can get up a graph. And we can plot the points. 0, -6. 4, 0. And all we need for our line is those 2 points. Connect them, and we have a graph using our x and our y intercepts. Second example, -3x plus 9y equals a -18. Again, we're going to get an x, y table to record our points. If we put in a 0 for x, 9y equals a -18. It's going to be 9 times -2 gives us -18. For the other point, zeroing out the y, -3 times a +6 gives us the -18 value. And once we have those 2 pieces, we can graph. We're going to need this -2 on the y and 6 on the x. 2, 3, 4, 6, 0 is right here. 0, -2 is down here. And so the line connecting the 2 points. Last example. 2x plus 6y minus 12 equals 0. Sometimes it's not written with just the x and the y term on the left, our constant on the right, and so we need to fix it before we do the intercept plotting. So to do that, we're going to add the 12 to both sides. 2x plus 6y equals 12. And now we can create our xy table. If I put a 0 in for x, 6 times 2 gives me 12. If I put a 0 in for y, 2 times 6 gives me 12. Go to graph this. Similar function to the last one. In that we got one of the intercepts the same, 6, 0, 2, 3, 4, 5, 6, 7. This time it's positive. So we have 0, 2. We have 6, 0. And connect the line. Okay, that completes review number 2.